Hi everyone, this is your notes video on parallel lines and angle relationships. As always, the slides and things you normally would see live in class are on the left side of your screen, and your student notes are on the right side of your screen. So in this video, I'm just going to go over what these angle relationships are, and then I have two practice problem videos for you on this topic. One is just straight like practice with these ideas, dealing mostly with numbers. And then there's one other on how you would write proofs and some examples of proofs in this with this topic. So with that, let's go ahead and jump into it. Okay, so I'm hoping that before now you've heard the term parallel lines. Okay, so parallel lines are two lines that are coplanar, just meaning that they are on the same plane. So like you would draw them on the same piece of paper, right? And they're simply lines that never intersect. So parallel lines are lines that never intersect. Okay, and the symbol for parallel is two. Actually, that's definitely not big enough. You can't really see that very well. Let's try a different one. Okay, so the symbol for parallel is two. It basically looks like an 11. Okay, so you can see it on the right side of your screen, but I'll also draw it here for you on the left side of the screen. So the way, if I, in this picture here, down here at the bottom in figure A, if I called this line L and I called this line M, I would say that I would write line L is parallel to line M. So that's the symbol. It's basically just two vertical lines. Okay. Then the other term that is on here that may not be familiar to you is this one, transversal. Okay, which is a line that intersects two other lines, two or more other lines at different points. So basically, you can almost think of it um, like a it's basically just a line that like cuts through other lines and intersects other lines. I know this game is kind of old, but if you ever played Fruit Ninja, it's like the knife, right? Like the path that the knife makes when you're slicing through fruit, right? That's essentially what a transversal is. So a transversal can intersect two lines that are parallel, like these two lines. So lines L and M in figure A are parallel, and we can have a transversal that's cutting through them, okay? Or it can cut through two lines that are not parallel. So, um, for example, in figure B here, you have these two lines that are definitely not parallel, because if we extend them just a little bit, it looks like they're going to intersect, right? Those are definitely not parallel. But you can still have a transversal that cuts through them, okay? Now, the way that I can tell that these two lines in figure A are parallel rather than um, rather than just looking at the picture, because the thing about doing stuff in geometry is that it's not always guaranteed. If something looks a certain way, it doesn't necessarily mean that it's like that it has that certain property. So like even though these lines look parallel, we can't know for sure that they're parallel unless either we are told that they're parallel or that you see this little arrow symbol, okay, on your on the lines. So it may be a good idea in your notes over here to draw a set of parallel lines with a transversal, right? And then the way you can tell is that the parallel lines will have these arrows on them that you can see kind of over on the right hand side that are there in purple. Okay, and then the last term that's going to be important for these angle relationships is this one, linear pair, which we've talked about before, but I'm giving you an actual like formal definition of it now, right? A linear pair is literally a pair of angles that makes a line, right? Pair, linear pair, right? So it's two adjacent supplementary angles. So when you have two lines that intersect, you have tons of linear pairs, right? So in figure A, you have, for example, 1 and 2, 3 and 4, and then down here at the bottom, you also have 5 and 6 and 7 and 8. But you also have like 2 and 4 are a linear pair, right? 1 and 3 are a linear pair. And the same thing can happen over here in figure B. Even though these two lines, F and G, are not parallel, you still have tons of linear pairs in here. The same ones that you see in figure A. You see 1 and 2, 3 and 4, 5 and 6, 7 and 8, and then again, we still have the other ones that are kind of going up and down. So like 2 and 4, and 5 and 7, right? There's lots of linear pairs here, okay? Right, and you'll see in class kind of how those come together and how we know how we use those linear pairs to help us figure out some of these angle relationships. All right, so let me clear my screen over here. Okay, so let's talk about these angle relationships. So you're going to see a bunch of definitions here, okay, but I'm going to show you a picture of all of these things, like of all of these angle relationships in a minute, that will be a lot clearer. Like it's easier to pick these out in when you have a picture of them. So just hang tight with me as I talk you through what they are, and then I'll show you what they look like. Okay, so your very first types of angles here are called corresponding angles. Okay, so the best way to think about these is that they are in the same location in their group of 4. Okay, so here's what I mean by that. If you have two parallel lines and a transversal, okay, you have two groups of 4 angles, right? You have this group up here at the top and this group down here at the bottom. And they all have, each has 4 angles, right? There's one in the top left, one in the top right, right? One in the bottom left and one in the bottom right. So what this says is that the angles that are in the same spot in their group of 4, so like these two angles right here, right? The ones that are both in the top left, okay, those are corresponding angles, okay? One thing that I want you to keep in mind is that all of these are angle pairs. It's a relationship between angle pairs, so you always have to have 2 angles there, okay? Right? So another way you can think about it is that it'll be like one of the angles will be, they'll be on the same side of the transversal, so either on the left or on the right of the transversal. One will be outside the parallel lines and the other will be inside the parallel lines, okay? So that's your, those are your corresponding angles, okay? Well, I'm trying to kind of illustrate as I go here, okay? So next, most of these other ones are, they're named in such a way that it kind of gives away like where they're located. Okay, so the second set here are same side interior angles. Okay, so same side means on the same side of the transversal, okay, meaning either both on the left side or both on the right side. And interior means they have to be inside the parallel lines. So for example, this angle and this angle together are same side interior angles. Same thing for the ones on the right side. Those are same side interior angles, okay? Right? Then you can probably guess that same side exterior angles, which is the next one here. So same side exterior angles are a similar idea. Right? Hold on one second. Similar idea, to the interior ones, right, that they have to be on the same side of the transversal, either the left or the right, but they have to be outside of the parallel lines. So like this angle and this angle are same side exterior angles, right? And then this one and this one are same side exterior angles. Okay? All right, so those are all of your same side angle relationships. Okay? All right, then the next term that you see there are alternate interior and alternate exterior. Okay? So obviously we've seen with the same side that we know what interior and exterior mean. So this next one here is alternate interior angles. Okay. And then the fifth one on the page is alternate exterior angles. Okay. Alternate means different or opposite. Okay. So that's what that means, right? This word alternate means opposite. Okay, so as you probably guessed, right, that means one of the angles in the pair has to be on, say, the left side of the transversal, and the other has to be on the right side. So I'm going to mark in blue here a pair of alternate interior angles. So that would be like this angle and this angle, right? So they're both stuck inside the parallel lines, okay? But one is on the left side of the transversal and one is on the right side of the transversal, okay? Then I'm going to mark some alternate exterior angles here in purple, okay? So they have to both be outside of the parallel lines. So, for example, this one and this one, okay? So they're both outside the parallel lines and on opposite sides of the transversal, okay? All right, and then the very last pair, the very last angle relationship is one that you have already seen. Okay, one moment, let me get my text box back. You've heard this term before. I've talked about this term before. Okay, but the very last angle relationship is vertical angles. Okay, so those are your mirror image angles, and they will always be in the same pair, or in the same group of four. Okay, so note these are always in the same group of four. Okay, all of the others, okay, all of these other ones, right, these other five will be in different groups of four. Like you'll have one angle in one group of four and the other angle in the other group. Okay, so these have to be in different groups of four. Okay, have to be in different groups of four. Okay, but the vertical angles will always be in the same group of four. So those are the ones that are right across from each other in an X that's formed. So you have like this angle and this angle, for example, are vertical angles. Okay, and they can happen in any group of four there. All right. Okay, so now I'm going to show you on the, let me clear my screen here on the left. Okay, but I'm going to show you a picture of these on the left-hand side, and that'll be a little easier to visualize, I'm hoping. Okay, so here are your angle relationships, right? So see, corresponding angles are in the same location in their group of four. So see, like top right, okay? Alternate interior angles, see how they're both trapped inside the parallel lines, but one is on the left and one is on the right, okay? Alternate exterior, same idea. They're both outside the parallel lines. One's on the left and one's on the right, okay? Or you could think of it as like if you have parallel lines that look like this and your transversal cuts like this, for example, right? You would have to have one on the bottom and one on the top, for example, right? So they just have to be on either side of the transversal. They can't be on the same side, okay? Then you have your vertical angles. See how these are in one group of four, right? So these two angles are both in the top group of four, and they're across from each other. I didn't involve any angles in the bottom group. Okay, and then you have your same side angles here on the right. So here we can see these two angles are both trapped inside the parallel lines, but they're both on the same side of the transversal. They're both on the right side of the transversal. And then for the exterior ones, they're both outside the parallel lines, but they're still on the same side. Like they're both on the left-hand side of the transversal in this case, okay? So now that we have an idea of what these are, okay, we have to know like that there's some relationships between them, okay? This only works when the lines are parallel, okay? If the lines are not parallel, this isn't going to work. Like the angle relationships don't hold up, okay? So there's only two possible types of angle relationships, okay? So you can see on the screen on the left-hand side that you can see like some measurements for two, and these are, I'll tell you, these are parallel lines cut by a transversal, okay? So if we look and we look at, say, our alternate interior angles here and here, okay, and then the other pair would be here and here. Okay, what we notice is that the alternate interior angles are congruent to each other, right? And that's always going to be true. I'm hoping that you can see with the numbers on the left side of the screen that all of the big angles, all of the obtuse angles are the same. See, they all have the same measurement, okay? And all the acute angles also have the same measurement, right? See that? All of the acute angles are the same in this case, okay? But this only works when you have lines that are parallel, okay? And here's why. Here's why this happens, right? If you have two lines, say like this, okay, and you take this line right here, and you make a copy of it, right, and just move it down, right? You just kind of shift it down. Like if you think about when you do copy and paste, right? Like on a like when you're working on a computer, right? If you take this, make a copy of it, right? And then kind of shift it down. Right? We take this and we move it and we shift it down. Right? It keeps the angle relationships, right? Like you're basically taking this group of four angles that you see here and copying it and moving it down here, okay? So we have all of our acute angles are the same and all of our obtuse angles are the same. So what that means is that all of these angle relationships, we're going to have a lot of these angle relationships where it will give you two angles that are congruent, meaning that their measures are equal, okay? So I'm going to write this for you on the right-hand side of the screen, and then I'll show it to you in a second on the left side of the screen. So the angle relationships that make congruent angles are the alternate interior and alternate exterior, okay? So those angles will be congruent. Corresponding angles are always congruent. Okay, that kind of goes back to this idea of taking this group of four and copying it and moving it down along the transversal, right? You're taking the angle in, say, like the top left and just kind of shifting it down, so they have to be congruent, okay? And then we already knew this, but vertical angles are also congruent. Okay, right? And then we have one other or a couple other angle relationships here that we haven't talked about, and those are the same side. Right? Those are the same side angles. Okay, so for example, if we do same side interior, that would be these two right here. Okay, and what I'm hoping that you notice is if you add these, right? If you add these two numbers, you get 180, okay? I'm hoping that it makes sense why that is, right? Because we see all of these linear pairs. Remember that we talked about at the beginning, right? We have all of these linear pairs, right? And remember, linear pairs have to add up to 180 because they're supplementary. Okay, so if we're taking this group of 4 at the top and copying it down here to make this second group of 4, then the same side interior angles, for example, will have one acute angle and one obtuse angle. Since they're all the same, if you add them, you're going to get 180. Same thing for the exterior ones, right? I have one obtuse angle and one acute angle, right? These are connected, so when we add them, they're equal to 180, okay? So the rule for same side angles, okay, so same side interior angles are supplementary, meaning that they add to 180, okay? Okay, so that's the rule, right? That's the rule. So I'm going to clear my screen on the left here, and then you'll be able to see all of these written out, okay? So we have here all of these angles. The only ones that are supplementary are the same side ones. So the best way that I've found to remember that is they all start with an S. Same side are supplementary. Okay, same side supplementary. Okay, all of the others will give you congruent angles. Okay, which remember, that just means that their measures are equal, right? Congruent is our fancy geometry word for equal. Okay, so and then another thing that this means, which we kind of talked about already, which is that all of the acute angles are congruent. If I could spell, that would be awesome. Okay, and all the obtuse angles are congruent. Okay, right? Always, okay? But, okay, and my last little caveat here, my but is that this only works for parallel lines. Okay, so this is not true if the lines are not parallel. Okay, and I'm going to show you what I mean. So if I have two lines, and I'm going to draw them here at the top of the screen. So if I have two lines that look like this, right, and I cut through them with a transversal, right? If we pick out, let's say, some corresponding angles. So like the angles in so like here are my groups of 4. There's that first group of 4, and here's the second group of 4. Okay, if we take a look at, say, the angles in the bottom left of their group of 4. So like this angle and this angle. Right? Those are obviously not the same, right? The one in the top group is much smaller than the one in the bottom group, right? So this only works if the lines are parallel, okay? But it does go both ways. So a problem could start by saying, these lines are parallel, right? They're going to give you two lines and say the lines are parallel. Okay, so then that means you know that all the angle relationships work, right? All of these angle relationships that you see on the screen. The same side interior, same side exterior, alternate interior, exterior, all that stuff. Okay, so that means that all the angle relationships work. Okay, and then it also goes the other way. So they could also tell you that that the angle relationships work, right? You may be able to show that the angle relationships hold up, right? And that means that the lines are parallel. So it's like when we're doing proofs and we do definitions, the definitions can go both ways. Like sometimes you start with the term and then you write the equation based on the term. And then sometimes you start with the equation and go to the definition. It's the same thing, okay? So uh, you can start with the fact that the lines are parallel, and then you'll know all of these angle relationships hold up. Or you can be given two angles and see and show that the angle relationship is there. And then so if you know the angle relationship works, then that means the lines must be parallel. So it goes both ways. All right. Okay, one last thing I want to make sure that you know for these, the non-parallel lines, like the ones that you see at the top left of your screen, the only angle relationship that holds up is this one, the vertical angles, because that's dealing with just like the two angles in the pair are in the same group of four. So it doesn't have anything to do really with whether or not the lines are parallel. All right, y'all. So that was a slightly long explanation for a fairly simple topic. But so in the next video, I'm going to show you, and we're going to do some practice problems with these ideas. And then there's, like I said, there's one other video for this topic that's just proofs on this idea. All right. So I will see you all in the next video. Bye, everybody.